Insulin is a remarkably important hormone in our bodies. Think of it as a diligent manager, constantly working behind the scenes. It is produced by a small organ called the pancreas, which sits just behind your stomach. Its primary role, and it's a crucial one, is to regulate the amount of sugar, or glucose, in your bloodstream. Without insulin doing its job effectively, our energy levels and overall health would be in serious jeopardy. It's a key player in how our bodies convert the food we eat into the energy we need to live, breathe, and go about our daily activities. Understanding this hormone is the first step to appreciating its significance for our well-being. So, how exactly does insulin perform this vital task of managing blood sugar? Imagine insulin as a tiny key. After you eat a meal, particularly one containing carbohydrates, your body breaks these down into glucose, which then enters your bloodstream. This rise in blood glucose signals the pancreas to release insulin. This insulin then travels through your bloodstream, and its job is to unlock the doors of your body's cells. By attaching to receptors on the cell surfaces, it allows glucose to move from the blood and into the cells. Once inside, this glucose can be used immediately for energy or stored in our muscles, liver, or stored as fat for later use. The more high a blood glucose spike is, the more insulin that has to be released. The more often carbohydrates are eaten throughout the day, the more insulin that has to be released. The more insulin that our pancreas has to release, the more glucose that gets stored as fat in our body. If blood sugar levels get too high for too long, it causes damage to blood vessels, nerves, cells, tissues, and organs. Blood sugar typically crashes after a spike after eating a high carbohydrate meal, making you might feel fatigued, agitated, or struggling to concentrate. Your brain in particular is very sensitive to spikes and crashes in blood sugar. Insulin, therefore, plays a central role in this delicate balancing act. It ensures that our cells have fuel and that our blood sugar levels stay within a healthy range. Let's consider what happens after a typical meal. As you digest your food, carbohydrates are broken down into simpler sugars, primarily glucose, which are then absorbed into your bloodstream. This spike in blood glucose acts as a signal to your pancreas to release an appropriate amount of insulin. This insulin then circulates, helping to usher the glucose out of the blood and into your liver, muscle, and fat cells. If your cells need immediate energy, the glucose is used right away. If not, it's stored as glycogen in the liver and muscles, or as body fat for future energy needs. Our modern diets, often laden with refined carbohydrates and sugary drinks along with ultra-processed foods, can put a significant strain on our insulin system. When you consume a bowl of breakfast cereal, a plate of pasta, or even a large glass of fruit juice, your body experiences a rapid spike in blood glucose levels. This sudden influx of carbohydrates forces your pancreas to work harder, pumping out a larger amount of insulin to try and deal with the sugar overload. While an occasional treat might be manageable, a consistent diet high in these types of carbohydrates and beverages means your pancreas is constantly in overdrive. This persistent demand can, over time, make the entire system less efficient and more prone to issues. It's not just the obvious sugary treats and refined carbs that pose a problem. Ultra-processed foods are also major culprits in disrupting insulin function. Many processed items, from ready meals and savory snacks to breakfast cereals and sauces, contain surprisingly high amounts of refined carbohydrates and hidden sugars. These refined carbohydrates, like bread, pasta, and pastries, are broken down very quickly by the body into glucose, leading to a similar rapid blood sugar spike as seen with direct sugar consumption. The constant exposure to these types of foods means our bodies are frequently responding to surges in blood glucose, placing a relentless demand on our insulin production and its ability to manage these levels effectively. After repeated chronic high exposure to insulin, the cells start to downregulate and not respond as effectively or efficiently, and eventually insulin resistance develops. This constant barrage of carbohydrates and the subsequent high insulin levels can be likened to a communication breakdown within your body. Your pancreas is shouting, releasing lots of insulin to get the cells to take up glucose, but the cells are becoming deaf to the message. They are becoming resistant to insulin's effects. We were never meant to have these chronically elevated blood levels of glucose and insulin. This is essentially toxic levels of glucose and insulin that cause inflammation on the inside of our blood vessels, structural damage to our nerves, and dysfunction of our cells. Structural damage to cells, blood vessels, and nerves then causes inflammation and disrupts the function and communication within our body. Blood vessels are no longer as efficient to deliver nutrients and oxygen to cells and nerves, and are no longer efficient at removing waste and toxins from cells. Long-term damage to cells, tissues, and organs starts to occur. Blood vessels develop inflammation and then atherosclerosis. This hardening of blood vessels with damaged inner lining results in cardiovascular disease, high blood pressure, and eventually heart failure. Waste and toxins build up in cells, tissues, and organs, contributing to DNA damage and increased risk for many cancers, along with symptoms of fatigue and pain. Oxygen and nutrient delivery are impaired, leading to organ dysfunction. There is no organ that is protected from high glucose and high levels of insulin. Because of insulin resistance and inflammation to our blood cells and cell membranes, damage may occur to our brain, lungs, skin, kidneys, testicles, ovaries, liver, eyes, and nerves. This is why insulin resistance is not only associated with diabetes, but also contributes to diseases such as Alzheimer's disease, cardiovascular disease, inflammatory skin disorders such as psoriasis and eczema, PCOS, erectile dysfunction, high blood pressure, infertility, chronic kidney disease, neuropathies, depression, anxiety, fibromyalgia, irritable bowel syndrome, and non-alcoholic fatty liver disease. Obesity is another condition that occurs from frequent and large blood glucose spikes that happen from carbohydrate and sugar meals, snacks, and drinks that provoke large insulin surges, resulting in storage of this excessive blood sugar as body fat. Insulin remains in the bloodstream for approximately 2 hours after eating carbohydrates, and insulin blocks fat burning if it is elevated during exercise. This creates a phenomenon where exercise during the 2 hours after consuming high carbohydrate meal inhibits fat burning. There are ways to increase fat burning. Firstly, do not snack in between meals. Snacking results in glucose and insulin spikes, causing prolonged and chronic insulin in the bloodstream. A lack of insulin in the bloodstream allows fat to be burned when we are moving and contracting our muscles. Try limit drinking calories. Fruit juices contain high amounts of fructose with no fiber, subsequently causing a large glucose spike, resulting in a large insulin surge. Also, consider the order in which we eat our foods. Eat protein, natural fats, and vegetables first. Consume pasta, bread, or rice last. Why? The protein and fiber slow digestion, which will decrease the rate of glucose absorption from the carbohydrates, reducing the level of glucose spike. Specialty coffees with sugar, syrups, and oat milk also induce large glucose spikes, provoking large insulin surges. Consuming less than 100 grams of carbs per day will also significantly reduce glucose and insulin responses. Focusing on and prioritizing consuming more than 100 grams of protein daily increases basal metabolism and creates the sensation of fullness that subsequently decreases the sensation of hunger in between meals. Being mindful of decreasing ultra-processed substance intake, which also includes lab-made vegetable oils. These substances, which are not considered food, compromise our cell membranes, contributing to insulin resistance because the insulin receptors on the cell wall are damaged and dysfunctional. Besides dietary upgrades, moving our body to contract our muscles after eating decreases risk of insulin resistance significantly. Contracting our muscles, such as walking or doing housework after a meal, requires energy. Our muscles utilize the glucose in our blood for energy before insulin has the chance to be released. Stress also disrupts metabolism and affects the way glucose and insulin respond, further contributing to insulin resistance. Adapting a variety of ways to decrease stress not discussed on this module will help minimize the risk for insulin resistance. Avoiding as many toxins as possible, such as glyphosate, mold, microplastics, and heavy metals, is also vital to maintaining healthy cells and blood vessels, which decrease risk of insulin resistance. Restorative sleep is vital to a well-functioning body, as it is during sleep that we cleanse our metabolites and toxins from our brain. Many good quality supplements help to maintain healthy tissue in the body, such as vitamin D3 and K2, omega-3 fish oils, magnesium, and zinc. Natural supplements to help reduce blood sugar spikes include berberine, chromium, and cinnamon. The goal is to not have frequent high blood sugar spikes that provoke high insulin surges. Our bodies need a break from insulin in our bloodstream in order to maintain insulin sensitivity. By decreasing the volume of insulin and the frequency of insulin release, we significantly decrease our risk of insulin resistance, which decreases our risk for or improves our chronic diseases, conditions, and symptoms. In addition, obesity is greatly improved by decreasing the amount of insulin in our bloodstream. In conclusion, managing your insulin levels and maintaining good insulin sensitivity is fundamental to your overall long-term health and vitality. Insulin resistance is a silent saboteur, but it's one that we have considerable power to influence through our lifestyle choices. By understanding how insulin works, recognizing the impact of our diet, and taking proactive steps to eat well, move regularly, and manage stress, we can protect ourselves from this condition and its associated health risks.